Welcome back to another Txe Prep video, and in this video we're going to look at problems number 16 and 17 from the 2020 AMC 10A. So let's just get started with question number 16. So this problem states that a point is chosen at random within the square in the coordinate plane 0, 0, 0, 2020, 2020, 0, and 2020, 2020. The probability that the point is within d units of a lattice point is 1/2. What is d to the nearest 10th? So basically, a lattice point is a point on the coordinate plane which has integers as its x and y points. So for example, 1, 1, 1, 5, 1,000, negative 1,000, but not something like 1/2, 1, or 0.5, 2, nothing like that. Basically, just a point with integers. So it's giving us a square, and let's just try drawing the square and seeing what happens. So if we draw the square, I have my point 2020, 2020, 0, and 0, 2020, and then I'm going to draw my box, and this becomes my point 2020, 0, or 2020, 2020. So we can take just one single box out of here. So this would be 1, 0, and 0, 1, and 1, 1, and apply the same question to just this box, and then the probability will be the same for the entire region because this is just a fraction of the box, and thus it'll have the same probability. So let's just magnify this box over here. So I'm going to draw my box, and here's my 0, 0, here's my 1, 0, and here is my 0, 1, and on the right is my 1, 1. So now it says that the probability that a point is within d units of a lattice point is 1/2. So in order to be a certain number of units within a lattice point, you have to be in kind of a radius from this point to outside. So it's going to look like a kind of a circle, kind of a quarter circle over here, and that's going to apply to every single one of these points. So I'm going to draw quarter circles for all of them. And then what we have to note is that the probability is 1/2, meaning that the area outside of the circles is the same as the area inside of the circles, right? So we can find the area of the entire box, and the area of the entire box is simply just going to be 1. But now in order to find the area of the circles, which is basically the d that we're trying to find, since the d is the radius for these circles, what I have to do is take pi r squared, and in this case our r is d, so pi d squared over 4, because it's a quarter circle, but then we have to multiply by 4 because we have 4 parts of the circle, so the 4's and the 4's just cancel out, and we're left with 1 minus pi d squared. So that's just going to be the area of these circles over here. And that's going to be equal to 1/2, because that's our probability. So what we can do now is try to simplify things. So we can change this into 1/2 is equal to pi d squared. And we can take the pi to the bottom and make this 1 over 2 pi is equal to d squared. Right? And in order to find, I'm going to move this up here. And in order to find d, what we can do is just take the square root of both sides, giving us 1 over the square root of 2 pi. So 2 pi can be represented as about 6.28. So I'm going to change this to d is equal to 1 over the square root of 6.28. And 6.28 is really close to 6.25. So I'm going to approximate this. To the 1 over the square root of 6.25. And the square root of 6.25 is simply just going to be 1 over 2.5. And thus, if we take it to the nearest 10th, 1 divided by 2.5 is simply just going to be 0.4. So that's our answer. D is approximately equal to 0.4. So that's our answer over here. So this is problem number 17. And this basically asks us that we're given a function p of x such that it's x minus 1 squared times x minus 2 squared all the way to x minus 100 squared. So how many integers are there such that p of x is less than or equal to 0? So the first thing I'm going to do is graph this out. So let's just graph this out. So that's our x-axis and this is our y-axis, and since there's going to be an even number of terms, it's going to start from the top. Like our polynomial, our function will start all the way from the top. So it's going to go down, and then it's going to intersect at 1 squared, which is just 1. and then it's going to start to go back up, and it's going to intersect at 4, which is 2 squared. Then it's going to intersect, come down, and intersect at 9, which is 3 squared, and then come back up at 16, which is 4 squared, and go to 25, and basically repeat this process until you reach 100 squared, and 100 squared is going to be something like 10,000. So that's 100 squared, so it's going to repeat that process all the way till there. So let's just start with small patterns, and then see if we can apply them to the entire problem. So how many numbers are going to be less than or equal to 0 between 1 and 4, and 1 and 4 are included? So 1 is 0, which means it fits the criteria. So 2 is also less than y is equal to 0, so that also fits the criteria. So does 3, and so does 4. So we have 4 terms over here. Okay, and how about over here? Well, we're going to have 8 terms. And between 25 and 36, we're going to have 12 terms. So it becomes clear that we have an arithmetic sequence. So we have 4, and then 8, and then 12, and we have going to have 50 of those terms, because there's going to be 100 total intersections, but only 50 of them are less than or equal to 0. 50 intervals are less than or equal to 0. So that means our last term is going to be 200, because 50 times 4 is 200. And now all we have to do is add these all up. So we just have to find 4 plus 8 plus 12, all the way to 200. And we can just use the arithmetic series formula for that. And what we can do for that is do the number of terms times the sum of the first and the last term, so 200 plus 4 divided by 2. And in order to find that, we can just simplify this into 50 times 102, which is just going to be 5,100, which is our final answer for this question over here.